Hi and Assalamualaikum. My name is Nur Nabila Najwani binti Muhammad Nazri from Group K25 Cayman Engineering. Now I will tell you about my maiden presentation IDP report. First, we look at our organization chart. Our project manager is Chow Tim Yi. For earthwork part, Nashwatul Umairah and Arif Wafi. For water reticulation part, Muhammad Jazali and Muhammad Mustaqim. And ESP part, Nur Hafiz, Ahmad Halwani and Muhammad Hassani. And the last is the costing and estimate part is me. Now we look at the project background. For project title is Pembangunan Susun Atur Perumahan di atas lot 3002, lot 3003, lot 3010, lot 3011, lot 166152, lot 166154, lot 166156 dan lot 166158. Mukim Pulai, Johor Bahru, Johor Darul Takzim. The description: the project is mixed-use development which consists of commercial buildings and also residential buildings. The development mainly including residential buildings such as cluster houses, terrace houses, and affordable houses. For businesses building, there will be a shop lot located at the entrance of the development area. Basic facilities such as electrical substation and detention ponds are also part of the project. Now we look at the site description. The proposed site layout for Zone A. The location of the project is very strategic and have an easy access to town. From Senai International Airport to project area is only required around 20 minutes drive, 15 kilometers. Nearest facilities to project area are Johor Premium Outlet, 7.69 km, Hospital Sultanah Aminah Paradigm Mall, Legoland, and Pulai Waterfall. Here is site development and site inventory for Zone A. What is component in Zone A are 2-story terrace house, 2-story cluster house, mechanical sewage plant, multi-purpose hall, primary school, religion school, mosque, affordable houses, retention pond, and water tank. From site analysis, we get highest point is 31.768 meter and lowest point is 22.503 meter. Here is a purpose level and cut and fill. Here we can see the purple part is fill part and the yellow part is cut part. Now we look at the earthwork, the processing of bigger quantity of dirt as well as a creation of holes and leveling of the ground surface are all part of construction project. We can see scope of work are clearing and grubbing, stripping topsoil, cut, transport cut to fill, fill to formation level, grading, compaction, and last is slope stabilization. For this project, we use a Microsoft Excel to perform a simple calculation using a grid method to estimate the volume. The volume difference between cut and fill cannot be more than 15%. We only got a 1.39% discrepancy between the cut and fill volume from the calculation, which is acceptable. For assumption used in slope analysis, we use Bishop simplified method calculation. Critical slope for our project is the slope that have more than or equal to 3 meter difference of purpose level. Calculation of critical slope by using Bishop method must find a unit weight, specific gravity, internal friction angle, cohesive strength, and the factor of safety. And we do 3 trial of slope stability. The conclusion for earthwork part: completion of earthwork within the specific program time is frequently the key to the project's on-time completion. Next, we look at a water reticulation. A water reticulation system is a system of pump, pipes, and water storage tanks that are used to store and transport water to consumers or inhabitants within a demand region, such as residential structures, commercial buildings, facilities, industry, and so on. For project design, this water reticulation system was designed to supply water for new development of housing and residential over an area of approximately 78.199 acres and with a purpose area over 202.244 acres at the Mukim Pulai, Johor Bahru, based on a guideline. Pipe network system. In this project, we propose to use closed-loop pipe network to analyze the reticulation pipelines for most of the building in the project. To get the peak flow rate, the average flow rate is multiplied by a peak factor depending on the location. This project used 2.5 for peak flow factor because the location of the project is in urban area. Fighting flow based on SPA and guideline for fire flow rate. This project used the housing scheme of Class C risk category with the average flow 1,370 litre per minute for whole housing area, and the highest number of story of the building is 2 story. The maximum pressure head in this site is 21.5 meter and the minimum pressure head in this site is 17.44 meter. Residual pressure head based on SPA and guideline. The recommendation for residual pressure is 7.5 meter for minimum and 30 meter for maximum. To calculate the head loss, this project used Hazen-Williams formula. Here we can see the formula. And for maximum allowable velocity based on SPA and guideline 2, minimum velocity of 0 m over s to prevent deposition, maximum velocity of 2.0 m over s to prevent abrasion in pump suction pipe, the maximum velocity 1.2 m over s to reduce problem with the cavitation. That I will present is ESCP. To limit the environmental impact of erosion and sedimentation, a plan that includes temporary measures that will apply during the construction phase and may include permanent measures that will remain in place until development is complete is required. For temporary earth drain, we refer to the Urban Stormwater Management Manual for Malaysia MASMA 2nd edition. To design criteria temporary earth drain, we use rainfall estimation. First, we look at average recurrence interval (ARI). Next, time concentration, and last, average rainfall intensity. And next, we look at peak discharge estimating. We use a rational method. One of frequently used method. And next, we calculate peak flow. After that, we do a hydraulic design of open channel. Here we can look at before that we look at flow rate, a Q, and we design temporary drainage using best hydraulic section, BS, BHS. Here we can look the design. And sediment control, BMPS. BMPS is stand of best management practice. First, will find soil loss using universal soil loss equation USLE. Second, we do estimate the sediment yield using modified universal soil loss equation MUSLE. And sediment control structure that located at the downstream of the construction to trap the excessive sediment. That's all from me. Thank you.